Chapter 11, Section 3 has us dealing with water scarcity. So we're going to talk about drought and climate and water shortages. We're also going to talk about the depletion of groundwater supplies, also diversion projects that redistribute water, and we'll talk about how the scarcity of water can lead to conflict and wars. The World Health Organization, or the WHO, considers an average of 1,000 cubic meters, or 264,000 gallons per person per year to be the necessary amount of water that a single person needs for domestic, industrial, and agricultural uses. So keep in mind that not everybody is using water on an industrial or an agricultural level, but we've looked at how much agriculture and industrial use of water is required just to sustain that one person, so it's spread over the population. About a third of the world's current population lives in countries where water supplies don't meet everyone's minimum essential water needs. So it's fairly common in some areas to use about 70% of annual river flows. Remember that these can be replenished pretty rapidly or recharged rapidly, but in some cases it's necessary to use as much as 120% of annual renewable resources. So if we are using over 100% of those renewable resources, we're actually dipping into some of our reserves for water. So we're going to be drawing on groundwater supplies and aquifer reserves. And obviously this is not going to be sustainable in the long run. The biggest problems in water stress and scarcity at the human level are going to occur in Africa and Asia. In both these countries, rainfall is very low, and they're also developing countries. They can't necessarily afford to adapt to these changes to build the infrastructure in order to deal with the water scarcity. We see some of these issues also in water stress and distribution being an issue here just in the U.S. if we think about the Southwest and places where water is scarce versus, say, the Midwest or the East Coast where there's a lot more water. So we see that on a smaller scale as well. As we said on the previous slide, local regions are going to vary in terms of their water scarcity or the water abundance. So this particular map attempts to show us general trends for water scarcity. So the orange is going to show us areas that have water scarcity, and the darker yellow is going to be stress or vulnerability. And notice that we see big portions of Africa and Asia, as we mentioned before, as being water stressed, as having a scarcity of water resources. Darker blue to these light dark shades of blue are going to be places where you're not water stressed. So we see in North America that we don't have the same water stresses as we see in Africa and Asia. Now, this is not to say that there aren't parts of Canada and the US that are seeing water scarcity or drought. This is just looking at the trend as a whole over a big geographic region. Many people lack access to clean water, let alone running water. More than 2/3 of the world's households have to fetch water from outside of the house. This is heavy work. It's usually done by women and children. Sometimes water is so scarce or so far away, this can take several hours a day just to have water in order to maintain your household for cooking and cleaning. Improved public systems can bring benefits to these poor families. So if we can bring water to the homes and prevent them from having to walk and carry heavy loads of water, that time can be better spent by the women and the children. Children can be sent to school and get an education. Women can also focus on tending to children. They can also focus on educating themselves as well as working outside the home to bring in an income as well. Also, with this, we can have increased sanitation, which, as we talked about before, is going to drastically reduce infectious diseases as well. So as we start to talk about drought, one thing we definitely have to mention is that drought can be very subjective. So in an area where you have an amazingly wet year, say in a desert, that could be considered a catastrophic drought in another region. So droughts are very regional and specific to their area. In general, though, a drought is going to be an extended period of consistently below average for that region precipitation that has a substantial impact on ecosystems, agriculture, and economics. So droughts are often cyclic. They come and go. We see these cycles as being 5-year drought cycles, 10-year drought cycles. Sometimes they can extend longer. We do know that land practices or soil conservation techniques can exacerbate their effects. So you can have water scarcity and then having poor land use practices. Those can make a combined effort to make a pretty horrific situation on a local region. And we saw this in the US. The worst drought so far that we've seen in economic and social terms was in the 1930s with the Great Dust Bowl. So there were a series of dry years combined with poor soil conservation practices, and these across the Great Plains came together in the perfect storm and created the Dust Bowl. So we had water scarcity. We weren't getting a lot of precipitation in the first place, but combined with poor soil conservation, we wound up getting a situation where during a gusty period when you had wind, which you do on the Great Plains a lot, the wind would pick up that dried out soil that wasn't being managed properly and there wasn't any rain to hold it down. It'd pick up that soil and it'd create these huge billowing dust clouds. And there'd be so much dust in the air that it essentially would turn day into night. And also, if you can imagine that much dust being in the air, what the air quality must have been like. So we lost a lot of topsoil through that, and it's really hard to farm when you have these billowing dust storms coming through, dropping sand everywhere. Because of this drought and poor conservation techniques for soil, thousands of families were forced to leave farms and migrate to other areas. And I would like to think, as of now, that we have better soil conservation practices that we're implementing in agriculture, so that when we do have a drought, we're not necessarily exacerbating it to the point of having a dust bowl, which is decimating to the Midwest. So as we're learning, droughts can be very catastrophic for human populations, and what makes them the most catastrophic is the duration of these droughts, and that really varies wildly. We talked about the Dust Bowl on the last slide in the 1930s. That drought lasts about 6 years, but we do have evidence that there were mega droughts that destroyed entire populations of people and entire cultures. In fact, the Anasazi culture was destroyed by a mega drought that lasted 25 to 50 years in the 12th and 13th centuries. So droughts are pretty serious and they can have a huge impact on human populations. In some of our previous podcasts, we talked a lot about groundwater supplies in aquifers and how these are very slow to recharge. We know now that our groundwater supplies are being depleted. In the United States, groundwater is being withdrawn from aquifers faster than a natural recharge can replace it. So we have a deficit of water withdrawal. We have more water coming out than is being put back in. On a local level, this causes a depression in the water table, so we're losing water from our aquifers. On a broader scale, if you have heavy pumping out of this aquifer, it can deplete the entire aquifer, and that's going to take thousands of years for that to recharge. So it's not considered a renewable resource because it can't recharge fast enough for us to reap those benefits. And this, your book uses a term, fossil water, because we're essentially mining water. We're taking something from the earth that we know can't be put back into the earth, or water cannot be put back into the aquifer in the time we would need it. So it is a non-renewable resource similar to fossil fuels for us. If we take out enough water from an aquifer, we are going to see aquifers start to collapse. Subsidence or sinking of the ground surface can follow. Your book brings up an example of the San Joaquin Valley in California, which has sunk more than 33 feet in the past 50 years because of excessive aquifer pumping. So that water is being taken out, and what's happening is that aquifer starts to collapse. When it collapses, you're decreasing the volume of space that water can hold. So you are permanently affecting that aquifer. It can no longer and will never again hold the same amount of water because you've decreased the space. Another consequence that we see of aquifer depletion is saltwater intrusion. This is where you have saltwater deposits being left from ancient oceans or the overuse of freshwater reservoirs. That can allow saltwater to intrude into the aquifers that we would use for domestic and agricultural purposes. And as we know, we can't have salt in our agricultural fields because plants can't grow in high salinity and animals can't drink water that has a high salinity either. Okay, so remember that the word subsidence is another word for sinking. So we're looking at the sinking caused by groundwater. This photo was taken in 1977, and this is in the San Joaquin Valley in California. And this shows the subsidence, or the sinking caused by groundwater depletion. So originally, we can look at this sign. This sign is where the ground level would have been in 1925. Remember that it sunk about 33 feet. In 1955, we can see the decrease by about half, or 15 feet, and in 1977, how much lower it is. When you see an image like this, it really brings home that an entire town, an aquifer, is starting to shrink or sink in size, and it really has a huge effect on removing the ability of this aquifer to ever recharge to its original volume. Diversion projects with water can actually redistribute water. So dams and canals are a foundation of civilization because they store and redistribute water for farms and for cities. We know there are a lot of great civilizations that have been organized around these large-scale canal systems. Some examples of those would be Sumeria, Egypt, India. However, our modern dams and water diversion projects have really grown in scale and in numbers. So we're seeing water redistribution at a much larger rate and a bigger scale than what we've seen in history. Despite the environmental costs. So there's a lot of environmental costs surrounding a damming project or redistribution of water. The efficiency of it, there's a lot of water that's being evaporated off, the cost of it, the loss of the environmental impact, or the loss of the river to the ecosystem. What is that doing environmentally? Right now, more than half of the world's 227 largest rivers have been dammed or diverted. So we're starting to kind of mess with the distribution of water through this. What you're looking at a picture of right now is of Lake Mead and the Hoover Dam, which is right outside of Las Vegas, Nevada. We're seeing kind of a similar situation where the redistribution of water is not sufficient for that particular population. So Lake Mead supplies about 40% of Las Vegas's water supply. It has started all these new projects to build pipelines to tap aquifers in another part of the state. They're also digging tunnels that will burrow into Lake Mead below the normal outlet, so they can still pull water from there, because right now they're pulling water from more of the top of the lake rather than the bottom, and that's not sufficient because the water level in Lake Mead is beginning to drop. As you know, Las Vegas is in the desert. It's very hot. It's very dry. The lake in Lake Mead behind the dam loses about 1.3 billion cubic meters of water each year just to evaporation. We're also seeing reduced flows into Lake Mead now that are really, because we're putting less into it and we're taking more than what can be replenished, we're starting to threaten the viability of this particular system as being a water source for Las Vegas. All right, you guys are looking at images of the Aral Sea, which is in Central Asia. It's kind of on the border of Kazakhstan and Uzbekistan. And the first image that we're seeing is from 1975, then 97, 05, and 09. But really, the biggest issue with this is you can see the volume of water in this inland sea. It's a very shallow inland sea, but it's an inland sea, is starting to decrease. It decreases dramatically. The issues started in the 1950s. The Soviet Union started diverting rivers that fed the Aral Sea. And they diverted those rivers to go to cotton fields and rice fields so that they could irrigate their crops and grow crops. Gradually, as the water stopped coming in to the Aral Sea, so we weren't replenishing that lake, the water started to evaporate from that area. When the water evaporated, it left toxic salt flats. Another side effect of having toxic salt flats is anytime the wind blows, you're going to get a toxic dust storm that's going to affect all the neighboring villages. The economic value of the cotton and rice that was grown as a result of diverting this water probably never equaled the cost of lost fisheries, the lost villages, and the health of the people living around the Aral Sea. Damming is another way of diverting water because we are impeding or stopping the flow, the natural flow into a river, into a body of water. International Rivers is an environmental and human rights organization. They report that dam projects have forced more than 23 million people from their homes, also from their land, and many are still suffering the impacts of dislocation years after it's occurred. And unfortunately, most of the people that are being displaced tend to be ethnic minorities in their countries. Several of the projects are in or adjacent to the Three Rivers World Heritage Site. There's 144 dams right now under construction, and several of those projects are threatening the ecological and cultural integrity of the most spectacular and some of the most biologically rich areas in the world. So dams can really change an ecosystem, and not necessarily for the better. There's also some increasing concern that big dams in seismically active areas can actually trigger earthquakes. There have been more than 70 cases worldwide where a large dam has been linked with an increase in seismic activity. So essentially, geologists are saying that filling a reservoir behind a dam can cause earthquakes. And in fact, they're suggesting that that happened in one particular earthquake in 2008 on the Min River. There's a dam on the Min River that caused a devastating 7.9 magnitude earthquake that killed an estimated 90,000 people. If that's true, that would be the deadliest dam-induced earthquake ever. But it pales into comparison with some other issues surrounding dams or potential catastrophes. Take, for example, the Three Gorges Dam on the Yangtze River. If that were to collapse and the water behind the dam were to be released all at once, one engineer said it would be a flood of biblical proportions for the over 100 million people that live downstream. So it's important to note that yes, we do need dams, we do need water reserves, we do have to divert water or we're not going to have enough of it. But what are some of the other implications, the unintended consequences of having these large dams as well? A lot of you in your discussions have already told me water is one of those resources that we have to protect, we have to conserve. It's going to be massively important, and you're absolutely right, because now we're starting to see people who are fighting over water as water becomes more scarce. Fortune magazine wrote that water will be to the 21st century what oil was to the 20th. We've seen skirmishes, if not outright warfare, over insufficient water already occurring. In Kenya, nomadic tribes have fought over dwindling water and grazing. These are people who got along just fine until water became scarce. They were actually quite peaceful. They coexisted very well together. One of the underlying causes of the genocide that's occurring in Darfur in Sudan is water scarcity. There's a large body of water that is drying up, and it's causing a lot of conflict. Water can also be used as a weapon. There have been at least 37 military confrontations in the past 50 years in which water has been a factor. We do know that Saddam Hussein cut off water flow to the massive Iraq marshes as a way of punishing his enemies among the marsh Arabs. And once he cut off that water flow to those marshes, the marshes dried up, and because there wasn't that water supply and the water had been diverted, it drove 140,000 people from their homes and really destroyed a unique way of life. This image comes to us from the Intergovernmental Panel on Climate Change, or the IPCC. And essentially it's showing us changes in precipitation for 2081, 2100 relative to the years 1986, 2005. So it's a model for changes in precipitation. So what we're seeing as a result of climate change is that freshwater shortages are becoming a lot worse in the future because of increased temperatures. This is showing us the best estimate from them on the likely changes in global precipitation. So we are going to see a lot less precipitation in a lot of areas, and we'll see a decrease in what our current averages are for precipitation. In combination with higher temperatures, which will then cause plants to evapotranspirate at a faster rate. The model suggests that decreasing water resources are going to continue to dwindle in many areas that are already water stressed.